We now find the area of the shaded region bounded by the curve given by f of x equals x cubed minus x squared minus 2x. And so we see that we have two regions. Let's say we consider this shaded region as A and this shaded region as B. So first we calculate the area of the shaded region A, and we also calculate the shaded region of B, add them together. We should be knowing that since this shaded region is coming below the x-axis, when we find the definite integral, this may come in negative. So we can just take its absolute value and add it with the area of the A to determine the total shaded region of this curve bounded from x equal to -1 to 2. So we have to first identify the limits. So here x equal to -1, and this point x equal to 0, and here x equal to 2. So first, let me write the formula. That is area under the curve of f of x, and this is given by integral from a to b, and then f of x dx, where a and b are the limits of x. That is, a is the lower limit and b is the upper limit. So first, I'm going to find the area of the shaded region A. So let's say this area is A, and this equals, we will put this definite integral. This is from x equal to -1 to the upper limit is 0, and we have to replace f of x as given over here. So let me replace f of x, which is x cubed minus x squared minus 2x times dx. So let's evaluate this different integral. We can use the power rule of integral, that is x raised to the power of n dx. If you have to integrate this, this equals x raised to the power of n plus 1 over n plus 1. So I'm going to use this integral formula to evaluate this integral. So first I can rewrite this integral as three parts, that is -1 to 0 x cube dx, and then we have negative x squared. So I can put this as negative of -1 to 0 x squared dx. We have negative 2x, so I take the 2 out of the integral and then put this as negative 2 times of integral from -1 to 0 x dx. So let's evaluate all these integrals. The first integral, when we use the power rule, that is, we have to integrate x cube. So therefore, this will become x raised to the power of 3 plus 1, which is 4, and divided by the same number, that is 4. And this has to be evaluated from -1 to 0 minus. Now we integrate x squared. So once again, if we use the formula, this will be x raised to the power of 2 plus 1, which is 3, and divided by the same number 3. And this is from -1 to 0. And also we have -2 times of, here we have x, so the power of x is 1. So we can write this as, when we integrate this will be x raised to the power of 1 plus 1, which is 2, and this is divided by 2. And this has to be once again evaluated from the limits -1 to 0. So let's continue. When we substitute this upper limit, we will get 0. So I put 0 minus of, now I plug in x equal to -1. So therefore this becomes -1 raised to the power of 4 divided by 4. Now let me do the next. This is, we have to evaluate the second integral. So we have negative in front, and when we put 0 for x, we will get 0 minus. Now I plug in x equal to -1, so it becomes -1 cube divided by 3, and we have, this can be cancelled for the next expression. So it's basically only x squared. We have to evaluate from -1 to 0. So I plug in x equal to 0. So therefore this becomes 0 squared, which is 0. And then I plug in x equal to -1, that is the lower limit. So it becomes -1 quantity squared. Let's continue. So this becomes, we have this -1 raised to the power of 4 is +1, but we already have a -1 here. So finally, this will become -1/4. Let me put this negative here, and this will be -1 quantity cube is -1. But since we have a negative here, this is a positive quantity, so it is 1/3 minus, and this is 0, but we have a negative, But this one, negative 1 quantity square, is a positive 1. But since we have a negative, it becomes a negative 1. Let's simplify this. This is negative 1/4, and this is negative 1/3, but this is a positive 1. So basically, we have to simplify this fraction. The common denominator is going to be the multiple of these two denominators, which is 12. So I put this 12 as a common denominator. So therefore, the numerator of this term has to be multiplied with 3, since we have this denominator 4. So negative 1 times 3 is negative 3. And then the numerator of this term has to be multiplied by 4. Since it is a negative 1, negative 1 times 4 is negative 4. And this has to be multiplied by 12 because the denominator is 1. So I put 12 here. So let's simplify this. So this is basically negative 7 plus 12 divided by 12, and this equals 12 minus 7 is 5. So we are getting 5 twelves for the first area, that is the area of the shaded region A is 5 twelves, and this is in square units. We now find the area of the shaded region B. So I'm going to write down this as area of the shaded region B, and this equals the limit is from 0 to 2. The lower limit is 0 and the upper limit is 2. And I replace this function f of x, that is x cubed minus x squared minus 2x, and then I put this dx. So let's evaluate this definite integral. Once again, we can use the power rule of integral to integrate each of these terms. Here I'm going to directly apply this power rule. So when we integrate x cube, we will get x raised to the power of 3 plus 1, which is 4 divided by 4 minus, and once again this is going to be x raised to the power of 2 plus 1, which is 3 over 3. And then when we integrate this negative 2x, we will get negative 2 times integral of x dx. This is when we use the power rule, we get x squared divided by 2. So these two gets cancelled. So it's basically negative x squared. So I'm going to put this as negative x squared. And this has to be evaluated from 0 to 2. So now let's replace the upper limit. That is, we replace the x by the upper limit. So when we do that, we get 2 power 4 divided by 4 minus 2 cube divided by 3 minus 2 square. Now we have to put minus and replace the x by the lower limit, which is 0. So when we replace the lower limit by 0, all the terms is going to be 0. So it's finally we get only 0 here. Now let's evaluate this value. 2 power 4 is 16 divided by 4 minus 2 power 3 is 8 divided by 3, and the 2 square is 4. You see that 16 over 4 is, this is basically 4. So we see 4 and this is negative 4. So these two gets cancelled. And this reduces to negative 8 thirds. But remember that since this represents the area, we can take its absolute value. So we take or we write down this area of the shaded region B, and this equals the absolute value of negative 8 thirds, and this equals 8 thirds square units. So this is the area of the shaded region P. We now find the total area of the shaded region, so which is represented by A sub t, and this equals area of the shaded region A, that is area of the shaded region A plus the area of the shaded region B, which we have already found. So we just have to add these two areas together. So area of shaded region A is 5 twelfths, and area of shaded region B is 8 thirds. Let's simplify this fraction. We put this 5 twelfths, and the common denominator is 12. So this fraction has to be multiplied and divided by 4. So 8 times 4 is 32, and 3 times 4 is 12. So we get these two fractions. Let's add these two fractions now because we have the common denominator 12. So it is 5 plus 32 divided by 12, and this equals 5 plus 32 is 37 over 12. So this is the area of the, or the total area of the shaded region. This is AT, and the unit of this area is square units.